Hey everyone, and welcome. Good morning. Thanks for joining us today. Today I am both the host and the presenter of our ECS webinar series. For those of you who don't know me, my name is Joe Belmonte, and I'm the Business Development Manager. We are going to be talking about erosion control BMP products for challenging solar sites. We're going to jump right in here, but I want to mention a few housekeeping things and tell you a little bit about who we are. You'll notice a chat box up in the upper right-hand corner of your screen there. Chime in and let us know where you're joining us from, and a little bit about environmental construction solutions. We're the one-stop shop in the Mid-Atlantic and Ohio River Valley for all things construction supplies, everything from erosion control and stormwater materials. We've got delivery trucks in all of those areas and can get product to you whenever you need it. So you'll see we're part of the W.S. Conley family of companies with some of our other sister companies there: Landscape Supply, Tin Barge, Walker Supply, and Chesapeake Valley Seed, which is actually very important to this webinar. We'll talk about why shortly. You can see all our locations there on the map, and we've been family owned since about the 1950s. We've got around 125 employees. I like to say we're big enough to serve you and small enough to want to. For any of you that are around Roanoke in October, on the 18th, which is a Wednesday, we're going to have a field day where we're going to demo a lot of erosion control and stormwater products. Come out and have lunch with us. There'll be a lot of vendors there to answer questions, a couple special guests to talk about some stormwater stuff and some ENS handbook revisions that's going on by DEQ. And it should be a really good time. You can register on our website. There's a field day tab at the top of the website. So a little bit about me as we get started. I've been around for about 2 decades in the construction supply industry, specific to erosion control and vegetative management, about a decade or a little more. I'm a certified erosion and stormwater program manager with Virginia DEQ. I'm very active in the IECA Mid-Atlantic chapter, which is the International Erosion Control Association. Some of you have heard me talk about that before. That's a great organization. And I've dealt mostly with very challenging sites as far as vegetation and erosion control over the last 10 years. Landfills, solar sites, mining reclamation areas, things of that nature. And so if you're joining us today, you probably already are aware of some of the issues and challenges on a mid-Atlantic solar site. Large open areas, poor soils, real erosion, sediment basin issues, vegetation. Do you seed first or after the panels are up? The challenges are there. Lots of them are similar across sites, but no one site is exactly like the other. Today, we're going to talk about many of those challenges as we've seen them over the last few years as this solar boom has come up into Virginia. We're going to talk about some BMP products, but also some processes that we've been seen and had success with, and how we may help moving forward. I've got some specific pictures and examples of these things used in solar across Mid-Atlantic job sites, but this info could really be used on any job site if you think about it. First and foremost, vegetation establishment. Chesapeake Valley Seed is under the WS family of companies, and it has been for about 5 years now. Chesapeake Valley works with an extensive network of farmers to source reclamation and native seed mixes, and we can create these seed mixes for any site you need. We routinely work with EPCs and even developers to help engineers craft the right seed mix for the particular location. We have one of the largest seed mixers, if not the largest, on the East Coast that I'm aware of. We're well versed in the state pollinator programs. We can help forecast job sites based on what cultivars will be able and be available in 6 months or a year when your job site starts versus when you specify it. Chesapeake Valley can also package seed mixes based on a contractor's needs. For example, we have a customer with a hydroseeder that each tank covers 1/3 of an acre. We recently packaged a native seed mix in 13-pound bags because that's what covered 1/3 of an acre. So his installers quite literally know to just pour 1 bag of seed in each tank of water. Many of you know the old Jimi Hendrix song, Hey Joe. Well, I get calls all the time, Hey Joe, I can't get my grass to grow. These are some pictures on the right here of solar farms that were having real trouble with vegetation. I typically respond with, let me see your soil test, and sometimes I get a blank stare. There are two pictures of sites I went on and had to dig up enough soil for soil test. These soils get very compacted throughout the construction process. Remember that state E&S handbooks don't require vegetation for aesthetics. Vegetation is your first line of defense for erosion. It holds the soil and helps infiltrate stormwater. And a good friend of mine always said, it's not rocket science, but it is soil science. And that's something I think that's becoming lost more and more over time. Maybe it's because we're moving further and further away from an agrarian society, but I'm on site with project managers often who don't know what cool season versus warm season mixes are, the value of a nurse crop or the role of pH in a soil. We can help translate all of that with soil test, recommending types of implements that can break up the soil, knowing when to plant and fertilize, really all of the above. We can talk an hour on each of these last few things I've mentioned, and we've actually done a lot of webinars of them. We have several webinars already recorded on our website that deal with fertility, picking the right seed mix, and more. You also need to make sure that what is being planted matches the specification and be aware of where your seed mixers are coming from. Here's an example of our Soil Defender reclamation mix. Notice several things. It has our name and address, purity percentages, origin, a test date, a lot number. If you were to pull a tag off of a job site and send it to me in the morning, by lunchtime, I would be able to tell you where all those seeds were grown, when they were harvested, when they were delivered to us, when they were mixed. I could tell you not only where the seed was grown, but probably who the farmer is. The term farm to table is kind of a buzzword in the restaurant industry. We could be called farm to job site when it comes to our seed mixes. And here's just an example of one of our native seed tags. Note that there's a few things different. I'd encourage you to check out our recorded webinar, Reclamation versus Native Seed Mixes, which one is right for your job site. It delves a lot into the differences between erosion control and contractor mixes and reclamation mixes versus native seeds and what some of the challenges are of getting them established. I bring all of this up because this is an attached seed tag from a job site in Virginia that someone sent me recently. And I've blocked out the name of the company. I'm not here to throw anyone under the bus, but there was no address. All three native varieties, only three native varieties. All three have 0.00 percentages. The inert matter, weed seed, and other crop conveniently equal 2% right on the nose. Folks, this bag of seed is very suspect, honestly. So have your EPC or your GC ask for the tags of seed bags at the end of each day if they're not doing that already. And seeding and fertilization are done together, but we need to start to think about fertility more than just at the time of seeding and standard 10-10-10 fertilizer. Here's a picture of a solar site, and the vegetation you see there has been there a year. The EPC didn't want to lose their progress, so they paid a contractor to put down a second application on the entire site, and they used an organic fertilizer. We stock many different fertilizers because of our turf and ornamental background. We can provide organic fertilizers, liquid fertilizers for hydroseeders, soil amendments. Typical ag-grade synthetic fertilizers only feed the plant. Organic fertilizers, on the other hand, feed the plant and also help the soil. They're generally more slow release, sending out nutrients over time that the plant needs. And it used to be that organic fertilizers were priced much higher than ag-grade synthetic fertilizers, and they weren't really an option for a large job site based on price and availability. That's really not the case anymore. Another benefit is that the NP and K are lower in nature, and they can be used in the summer. And so what I mean by that is that the previous picture was actually taken during an application in the summer. If you don't get a rain right away, that organic fertilizer isn't going to burn up the plant. So what all of this has evolved into, based on our knowledge and working with seed and fertility, is that our company has started doing vegetation management plans. We've done them with solar developers, EPCs, general contractors for some pretty tough energy sites. A vegetation management plan is anywhere from 4 to 20 pages, depending on the scope of things. We come out and take soil tests. We address the things like pH and when to add lime to the soil. It includes a fertility plan. It lists out a seed mix to be used. It talks about the topsoil on site, what erosion control blankets to use, what hydroseeding options to use. And we can do this in conjunction with the civil site engineer as well. So we didn't invent the vegetation management plan, but we've started to do it as a necessity for better job site performance. Many large solar developers and EPCs are starting to hire vegetation management positions to complement site supervisors and environmental employees. You've got to get vegetation established to help erosion and stormwater, right? But the key word here is that engineers specify establishment. Remember, vegetation establishment and vegetation management are two different things. And I'd like to add that if you're doing these plans now, or if you're not doing vegetation management plans, it's a great time to start. And I'd like to remind you that it's better than just taking cut and paste specs from old state E&S handbooks. They have some really outdated and some temporary seeds that they use, or cultivars that are now considered invasive. Does anybody know what this is here in this picture? Send me a note to the chat box if you do. This site is completely eat up with this vegetation, and it was planted as a part of the temporary seed mix. It's over 800 acres on this solar farm that we're working on, and I'm starting to see some replies here. And yes, you're correct. It's Serratia lespedeza. There's a site we're working on now trying to eradicate this and get some clover maybe and fescue, maybe some natives planting in there as well. And so while this lespedeza is in the grasses category, it's kind of a woody stalk. When it's cut, it clogs up the outfalls and stormwater ponds. It can be a real mess when it takes over the site. So in a nutshell, these vegetation management plans work. You can see the picture up here on the top is a reclamation mix that we established. The bottom left is a stormwater channel, and when you have that much vegetation, you really don't need to worry much about sediment loss. The sediment pond picture is one of my favorites. The water is so dirty because the sediment basin is working. Many of these sites create these basins first, and the sediment runs down into the into the basins. And we know this will settle out before the water is released. It looks like I've got a question coming in here. It says, what's the best time to get a vegetation management plan done? Great question. Well, anytime really. We've done them for projects before. They've started in the middle of a project. We're actually working with a few energy companies currently on post-construction hotspots to get a better vegetation established. And so this is a picture that I get, some pictures that I get emailed. One's very similar to this a lot. And they ask me, hey, Joe, how can I fix this? So if you look at the picture on the top left, you have some erosion in an open area. I took that picture, and you can imagine that the stormwater pond is behind me, but the drainage ditch going down to the sediment basin rather. The sediment basin is behind me, and the drainage ditch is off to the left. And so that's just a matter of where there wasn't great vegetation there. And as sheet flow has come off the panels, you can see there it's created some real erosion. That happens under the panels as well, from sheet flow from time to time. Other things you get, you have to remove check dams, and if that's an implement or a rock check dam, typically there's no vegetation under that. And so we're going to talk a little bit about some BMP products that I think not only can fix this, but can be used from the standpoint of a design feature from the beginning of the product. So as we move through these next slides over the rest of the presentation, these are products that we've seen that show a lot of promise on sites from engineers that have specified them, but also used in a kind of a Band-Aid fix or a reclamation of a bad area on a solar site. And to think about that, let's start thinking about these products from kind of the outside of the project going in. And so you can imagine as vehicles or large trucks or dump trucks leave a site, they can get the roads muddy with mud coming off of their tires. We have a construction entrance. You typically have to refresh stone. And this is a new product that's great for that. This is a FODS track out control mat. It is placed as an exit, and vehicles drive over it. It has pyramids that are about 3 inches in height, and these are 12 by 7 in the direction of travel. And so what they do basically is as vehicles go over them there, you can see the inset picture in the top right. The tires are indented just enough from the weight of the vehicle to actually allow the mud and debris to drop out of the tire tread, and it captures it in the actual track out control mat. Now, I've seen large, vehicles go over this. I've also seen a Toyota Prius go over this. Cars, trucks, any vehicle really can get over this leaving a job site. Again, it's 12 by 7 in the direction of travel. The pyramids are about 3 inches in high. This has about a 10-year lifespan. You can secure it down with 18-inch pins, and there are 7 of them in that picture on the left. It took about 30 to 40 minutes to install that. So in many states, we're seeing this as an actual, used instead of an actual construction entrance, meaning you can put this down right on the ground in lieu of rock and a fabric underneath it. Now, Virginia, where this picture was taken, is not quite there yet. So what we see these specified a lot for is instead of a rumble rack or instead of a wheel wash, they do a lot better job than either one of those, I think. And these have to be clean just like any other erosion BMP. You can see they're starting to get some mud build up in there, in between the panels there, in between the pyramids. And to clean them off, you can shovel them out. You can get a brush attachment for a skid steer. Some contractors will actually pick them up and flip them over and just reinstall them. Really depends on what you've got to work with on site. But they're really easy to use, really easy to clean, and they do a phenomenal job keeping mud on site. Another thing we work a lot with is geosynthetics, and this is a realm of products that have really evolved in the last, say, 10 years to 15 years. The geosynthetics that are used now, they're more than just a separation between the rock and the mud underneath it. They actually filtrate. They can confine things, just any number of things that you can use these products for. Where you only have to use one, whereas typically you used to have to use a fabric for separation and a grid. Some of these higher end geosynthetics are wonderful to just use one underneath it. And why that's important in talking about that is that, if you see these on a site, you really need to hold that specification, because the benefit of these is that, some of these higher end fabrics may cost more than an old traditional fabric, but when they're engineered right, you might need 9 inches of stone instead of, say, 15 or 16. So if a contractor, doesn't realize or have never used one of these before, and, then he just wants to use an older product or a cheaper product, well, if he follows the spec and puts down, that 9 inches of stone, well, then you're going to have some rutting, then you're going to have some issues. So it's important that you hold these specs, or if you need to, we can value engineer this, help you on a site for savings. A lot of you have probably heard us talk about Fleximat before, or Tide Concrete Block Mat is a non-proprietary name for Fleximat. It's a 5,000 PSI concrete embedded into a polypropylene geogrid. And it is great for uses instead of riprap on in channels and spillways off of dams, things of that nature. It is used extensively in solar. We're really seeing a lot of this used in solar around the Mid-Atlantic, not only from the specification side, but to solve problems later on. And here's a picture of it just as it's starting to vegetate. You actually you seed and then roll out the Fleximat on it over the seed, which is a little counterintuitive. So there's a lot of possibilities for Fleximat and solar. You can see this one has been used in a roadside ditch. You can imagine the top left there is it's been trenched in, and then it's been trenched in on the right side as well, and the road has just been brought right over top of it. Of course, you need to shingle it in the direction of the water flow to make sure that water doesn't get underneath it. They also make 8x30 smaller ones that we can deliver on a pallet. And why that's great is because it's great for retrofitting. You can see the picture in the bottom right there is where some riprap failed, and they pushed it all down to the bottom, and then they put some seed down, and they tucked that Fleximat right underneath that pipe coming out there and secured it in. And so that will now be a vegetated channel, whereas before it was just an unvegetated riprap channel. A lot of benefits to Fleximat as well with regards to the water quality, because these are areas that are now vegetated where they used to be just riprap. You have a lot lower water temperature and sustainability aspects from that, as you know, when you think about the downstream water temperature. And so these things can be delivered to solar sites based on a takeoff. Fleximat makes this in a mile-long old railroad bed. This is a solar site in Virginia, a spillway, and you can also see it's coming into the sediment pond as well on the far side of the picture there. And what's great about this is, you know, some of these might be 12-foot wide by 30-foot long. Some of them might be 16-foot wide by 50-foot long. They make several different sizes there, 8, 10, 12, 16 wide by any number of length long that you need. And so Fleximat will do a takeoff for a contractor and send back a picture of the takeoff with the numbers on it. And then they'll spray paint the numbers on the side of the actual Fleximat. So you can see there when it comes to the site, a contractor can actually look at the plans and kind of really put it all together like a Lego set or an erector set maybe. Makes it really easy for the contractor to use. So remember when I talked about our process and instead of actual products, and this is kind of a picture that I show a lot. Somebody sent this to me. This is on a basin on a solar farm in Virginia. And you can see there's no vegetation going down the sidewall there on the back side of the picture, with the exception of down low. So, you know, let's think about what happened here. It could have been that there was an erosion control blanket there, and the seed, you know, it wasn't pinned in enough, and the seed migrated down below, and all the seed it kind of ran down the hill and vegetated down at the bottom. Or it could be that they put too much nurse crop in here, and that it looks like there is some vegetation there that maybe has died out. Could be that too much annual rye or too much millet was used and it choked out everything else. But the point of this is that, you know, whether it be something as simple as seeding or something that's specified in a erosion control sense by an engineer like a Fleximat or a FODS, you know, utilize your reps and your manufacturers for training. So to try to mitigate some of these things, you know, your GCs or subs, if they're using products for the first time, you know, have a rep on site for the on-site delivery. You know, check your installation guidelines versus what's actually being installed out there. If you're a specifier, an engineer, or with a civil firm, or an engineer with an EPC or a developer, you know, if you're using a product or specifying it for the first time, you can actually specify that the GC on site has a meeting with a representative from the distributor or the manufacturer to really talk about proper installation techniques. And so that's a lot of what we see on solar sites when things become challenging, is that, you know, you have a lot of contractors that are coming from one state to work in another. They're bringing subs from one state, or they're hiring new subs that they've never worked with. And so you really need to be on the same page with a lot of these products when it comes to installation. And, you know, let your manufacturers or your distributors help with that is the point there. The other thing I like to talk about is not all blankets are the same. You know, I put this picture of Linus up there because he loves his blankets. You know, everybody, when you talk about rolled erosion control products, which are RECPs, or the term ECB, which is erosion control blanket. There's so many different kinds of them now, and there's a lot of trade names that contractors and even engineers use, speaking generically about these products. And what I mean by that, if I say, "Hey Sam, let's go and get a Coke," let's stop at the Wawa and get a Coke, I'm probably going to go in and get a Pepsi. So folks call Curlex blankets straw blankets, and straw blankets Curlex blankets, and they call TRMs blankets, and there's just a really huge difference in all of those things. And we kind of talk about some of the ones we use a lot and why. A Curlex blanket is I think a lot better for the money than a straw blanket. Curlex fibers are actually wood fibers, and so they swell when they encounter the water. They hold about 18 times their weight in water. They don't float like a straw blanket. As they degrade, there's a little more biomass to help with vegetation. So it's really a great temporary erosion control blanket. And you can see here is one that's been used, maybe this picture between the panels here with the blanket. Maybe they just didn't get good vegetation. Maybe it was kind of something that turned into a roadway where construction traffic was. Could be anything. But the best part of this picture is you can see on the left where they broke up the soil before they actually planted and used this. These products are great, but they're not magic beans. They're not magic. You need to abide by the basic rules of vegetation when you're using all of these. You need to break up the soil. If it's compacted due to construction wear. Turf reinforcement mats are a permanent erosion control blanket. These will essentially be here throughout the life of the product. They're not going to degrade. These are made from most of them polypropylene. This is an ECB 10 ounce turf reinforcement mat. If you're from Virginia, this would be an EC3. In Virginia DOT's list of erosion control blankets. You can also see some Filtrex compost filter socks that are used to kind of baffle the water coming down that ditch there. And this was an area where they needed to get vegetation, after the fact in this ditch line between the array and the road. But, you have water flow in between there. You have a good amount of water flow, so just a traditional blanket wouldn't use. Which brings us to a good question somebody asked here. How do you know whether to use a blanket or a reinforcement mat versus something like Fleximat in a position like this? Well, that's really an engineer's question based on several factors, most notably shear stress and how fast the water is coming down there. We'll talk about some of the shear stress numbers on all of these rolled erosion control products in a minute. Here's another one that we use a lot that I think is kind of a hybrid. It's a North American Green SC250. So this is a turf reinforcement mat. So it's a permanent erosion control product, but the weave on it is a little open. You can see the grid there in the top inset picture. Grass grows through it easily. And the SC in SC250 stands for straw coconut. So they've overlain straw and coconut on top of this turf reinforcement mat as one product, and you unroll it and it's all there. So it gives you the benefit of a TRM, but it also gives you the benefit of the water holding capacity and kind of the degradation of that biomass that will aid in vegetation over the long term. It's also interesting to note that, like a lot of things, these rolled erosion control products or ECBs, whatever you want to call them, have really evolved, and there have been a lot of new products in the last decade or so. And so there's now a category called a high performance turf reinforcement mat. Here's one used in a channel. And basically what separates this from a regular turf reinforcement mat is the shear stress, and you can use this in channels with greater shear stresses as well. So if you're looking at turf reinforcement mats versus high performance turf reinforcement mats, remember that that's all in kind of the same group, but that's not really an apples to apples comparison. If you're comparing the two, it would really, I guess, be more like an apples to orange comparison. So the other thing we like to talk about is that sod staples were really invented for sod, and they are used oftentimes with blankets, temporary erosion control blankets. The 6-inch or 12-inch sod staple will be fine. But when you get into turf reinforcement mats, you really need a better product, like maybe a J hook or a 12-inch with a washer pin, or some of the hex pins that you see on the left there. Here's an example of a Falcon hex pin. They have several of them that are, the ends are different configurations based on what kind of soil you need. They also have a chuck that you can use to take a drill and screw them in the ground. So, but the bottom line on that is, if you're using a turf reinforcement mat, you really need to look at the manufacturer's recommendation for how to secure it to the ground and get that intimate seed to soil contact. I see blankets and TRM specified all the time on plans, but I don't see any specification of what pin to use or what mechanism to use to secure it to the ground. And that's just as important. If you were building a Lamborghini to go and race on the Autobahn, you wouldn't get the cheapest, skinniest tires. Probably you'd get something that really holds it to the road, right? And so again, here's it's the same situation with erosion control blankets. And so as a wrap up, remember, think of rolled erosion control blankets on site, whether you're using them in a specification sense or whether you're using them to fix challenging areas on site. You have your basic temporary erosion control blanket is really aiding in vegetation. It's gonna cover that seed. It's going to create some biomass as it degrades. But they're really mainly only for seeding. The shear stress on those things are typically all under 3 pounds per square foot. Curlex blankets are a little more. Then you get into a permanent erosion control blanket, and that's when you need to think about the fact of it being reinforced vegetation. Like, remember those TRM, it's how they're made of polypropylene. They're going to be there for the long term. That's a permanent erosion control blanket. The SC250, like we talked about, has about a 10 pound per square foot shear stress. And then when you get up into HP TRMs, you get higher into maybe 17 to 19. Fleximat is really a unique product. It's kind of a TRM, but it's used in a lot of other situations other than that. But unvegetated, that has a 24 pound per square foot shear stress factor there, which makes it such a great heavy duty product for use on solar farms especially. So some of the other products we talk about are Filtrex compost filter socks. A lot of you have used those before or have seen these before. It's a mesh tube with a compost in it. It's used to baffle and filter water. It can be used as perimeter control. It can be used as a check dam. It's used a lot on solar farms for any of those reasons. One of its great uses is as slope interruption. And, we don't see a lot of slope interruption on plans these days. They're on most state handbooks. But you can see there where the arrows are pointing in the top picture. Those Filtrex compost filter socks are put across that hillside. So as water is coming off of that, it's actually slowing down the water as it's coming down the hill and going to the ditch line. The same thing with the picture on the bottom right. You can see there that, it's interrupted on the slope there. You can also use this in between panels to slow down sheet flow, like you've seen there on the picture on the left. Notice also the picture on the right. Those filter socks are white. That's because they're made out of cotton and they're biodegradable, where you can just plant around them and essentially leave them there for forever, essentially. So a lot of these blankets, and also going back to straw blankets and temporary erosion control blankets, a lot of those are made now with complete 100% biodegradable materials. So, you can put it down and it just goes away over time. Here's another example of some compost filter socks being used in solar. The one on the right is just used to kind of baffle the water and slow it down going into the ditch there. The picture on the left is actually a combination of maybe some perimeter control, and also it's used as a drip edge on those panels. I think they were trying that out to see how it did with the water coming off the panels and hitting the sock instead of just hitting the ground. I also talk about hydroseeding a lot when we talk about large scale projects, and hydroseeding, like anything else, it's just there's a lot of new products than there were maybe 15, 20 years ago. Hydroseeding and hydroseeders really kind of made their bones years ago as highways were being built, and it was mostly temporary seeding that was being done. And so different folks have different ideas of how effective hydroseeding can be, but I can tell you it can be incredibly effective on a large site like a solar site. I put the picture on the bottom left there because of the slurry being mixed up. The hydro mulch that we're going to talk about, the different kinds of them, they can actually come in a bale, a compressed bale, like if you bought a bag of peat moss at the garden center at a Lowe's or Home Depot, and then you put them in with the seed and lime and fertilizer. And that's what's great about hydroseeding is it can be kind of like bathtub gin. You can just mix up exactly what you want to. But again, the picture on the left is a picture looking down into the tank as it's starting to be mixed up. Not everybody gets to see that from the top of a hydroseeder. What's also interesting about it is understanding the types of hydraulic mulch that are out there now. So we deal with Profile mainly. They're the leader in hydromulch and hydroseeding materials. And so you can seed with things like a wood fiber matrix that you put in the tank with everything. You can put some tackifiers in there. You can have a paper mulch, which is made with cellulose. You can blend. There's a blend of both paper and wood, but those are really seeding mulches. When you start getting into flexible growth mediums and bonded fiber matrices, those are products like Pro Matrix and Flexterra that some of you in the industry may have certainly either used or heard about. Those are actually erosion control mulch products, and what I mean by that is they will hold the soil even without the seed, if that makes sense. The products on the left are really more like a seed aid. Certainly the tackifier helps hold it to the soil, but to give you kind of an impression of that, or an example of that, I should say, this is Flexterra, and these things form a chemical bond with the soil. So this is a picture that was sprayed the day before, and the fella actually picked up the Flexterra, and it was attached to the ground. And so you can put this down, and it will bond to the soil. So that's quite literally the dirt underneath what was hydroseeded that came up when he pulled up the Flexterra there. So again, these two types of hydraulic mulchers are actually used typically on steeper slopes, although they can be used in flat areas as well. But they're actually an erosion control product. They're not just a seed aid. And most states now are recognizing that in both ENS handbooks and DOT type materials listings as well. So I like to show this picture often. The picture on the left is a very poorly applied hydroseeded area. You can see a lot of the dirt. If that was seeded, it's not going to do well. The first rain is going to kind of push all that seed down into the channel there, and you might get a flush of grass there because it's all in one area. The pictures on the right are how a successful hydroseeding can look. Now, all of those like the bonded fiber matrix, Pro Matrix, and the Flexterra, and even the wood mulches and the seeding mulches, they all have an application rate. And those application rates are based on the gradient of the slope. So whichever one you're using, you might use less depending on the application rate if you're doing more of a flat area, and more if you're doing a hillside or in a solar farm where these higher end mulches are used a lot, or on the outskirts of channels and on the side walls of the sediment basins because there's some slope to them. But again, the picture on the right is how it should look. You can tell that that's been tracked upwards with a dozer, and that's a big part of erosion control in general. As rainfall comes down and goes down the hill, it has to maneuver through those tracks, and it literally slows the water down. And then on top of that, you can see good coverage there. You really can't see any ground because of that. So another question I get often is, hey, it's not green anymore. Is it still working? Understand that when you spray out the hydromulches, some of them are blue, but the majority of them are green. But that is a dye that is put in the hydromulch just really so the applicator can see where he's applied the product. That will fade out over time. And in this instance, you can see the picture on the left, the material is still working. That's either a Pro Matrix or Flexterra. It's still bonding to the soil. It's still gathering water and creating a seed bed, but it's just in a time frame where they did this and they didn't get rain immediately. Maybe they waited a week or two, and so that there was no vegetation, but the dye faded out. Here's the same place on the right. You can see the grass has started to grow in after some rain. So understand that just because it's fading out doesn't mean that it's not working anymore, if that makes sense. And so I talk about hydroseeding uniformity a lot. We have a product called HydroSmart, which is a liquid fertilizer that a lot of hydroseeders are starting to use. They like it because it gets the nutrients right where you need it. A lot of hydroseeders, have an older machine, and ag-based fertilizers or lime really kind of stresses their pump as it pumps the slurry out of the machine out onto the site. But when you think about these reclamation seed mixes or native mixes that we talked about in the beginning of the webinar that are on a lot of these renewable energy sites and pipelines and anything, imagine a handful of fescue. You might have 150,000 seeds in your hand. Imagine in the other hand, you have a handful of clover or a native seed or Bermuda. You might have literally 1 million seeds in your hand. So when you put all these into a hopper behind a tractor or a whirlybird spreader or a broadcast spreader, a lot of times the lighter weight seeds kind of come up to the top, and you don't get a great uniform growth pattern of all of these reclamation mixes or native seed mixes. So that's one of the real benefits of hydroseeding, is that the uniformity it can create by putting all of that stuff in the tank and then spraying it out over a given area. This is how a lot of hydroseeding is being done in mid-Atlantic solar sites with the hose. They're pulling the hose off the machine. They're not spraying the hydroseeding materials off the top deck or the top gun, like they call it. They're actually pulling off the hose and going under panels after the fact to seed this. And I also like to show this picture because if you're a GC or an EPC or an engineer figuring out the cost of all of this, understand that when that hydroseeder tells you it's going to cost more for hose work, he's not trying to pull the wool over your eyes or just get one over on you. You're going to need more folks, maybe 4 people instead of 3, or maybe 3 people instead of 2, to drag out the hose. Some of the hoses are 200 or 300 foot in length. And not only that, you might have to put something in the tank to increase the viscosity to get the material throughout the hose, or you might actually have to put less material, less hydromulch in the tank to get it to pump it all the way out to the end of the hose. So bottom line, when you do hose work on a site, whether it be a solar or any site rather, it's going to be a little more expensive than just open area seeding and being able to ride that hydroseeder down there and shoot seed and fertilizer and everything right off the top gun, if that makes sense. So just be aware of that. The last product I like to talk about, and we'll entertain some more questions, is there are a lot better silt fence options out there than this. This is a failed wire-back silt fence. Typically, silt fence, there's a lot of newer options out there, but you don't see it all the time because the evolution of silt fences hasn't caught up with, or excuse me, let me rephrase that. I should say the old ENS handbooks in most states haven't caught up with the evolution of silt fences, and folks still use wire back and chain link super silt fence. That fabric that's used on there is essentially has a flow rate of about 8 gallons per minute. So that silt fence is just that. It's a fence. Water is meant to hold up behind it, and the sediment drop to the bottom as the water slowly infiltrates out. But in a big rainstorm, things like this, sometimes it fails for any number of reasons. This is a poor installation as well. You can see to the left of the trash can there that, the silt fence is meat, and there's an open place there for water to get through. They're not tied together. But anyway, there's a lot of newer options out there. One that we use a lot is called a woven belted silt fence. And this is actually on a solar farm in Axton, Virginia, where super silt fence was specified. The contractor had worked with this before. They wanted to use this, and they got it approved by the engineer with our help. And you can see there that sediment is up almost to the top of that silt fence there after a huge rain that they had right after the silt fence was installed, when the area was just open and bare ground, and they were really at the beginning of construction. Now, I doubt wireback or even super silt fence would have saved this. The silt fence probably would have ripped. A lot of that sediment would have been down in that creek that's down there. It would have been a real mess. Now, like any BMP, this needs to be cleaned out. That's a lot of sediment that needs to be moved, but I think it speaks volumes to the strength and the flow rate of this fence, and we'll talk a little bit about that now. The woven belted silt fence, one of the biggest things about it, this is a two-stage, is that if you remember that that flow rate on those old silt fences of about 8 gallons per minute, we'll take a look at the right picture there of that silt fence. The bottom third, of course, is going to be under the ground, and the middle tier there has a flow rate of about 80 gallons per minute. In the top third of it, you can see through it easier. That's because it's a more open weave, and it has what's called a stormwater release. So as water comes down in a big rain event, like what happened in that last picture, the top is going to release water at a rate of 300 gallons per minute. So this is commonly known as a high flow silt fence, and a lot of states are starting to look at these. Virginia, for example, is redoing their ENS regulations and their ENS handbook. DEQ is working on that as we speak. I've been to a lot of the meetings as a member of the public, and I've actually been really impressed with that process. But a high flow silt fence is going to be in the new Virginia ENS regs. And so the other thing that makes this work is because not only does the flow rate run through, but there are actually, remember I called it a woven banded silt fence. There's actually bands, the belts that run through the silt fence 3 or 4 places throughout the width or the height of the silt fence. And that adds stability to the silt fence, much like a cable does on a highway median. The belts in the silt fence react to sediment pressure that way, so that the weight is distributed not only where the sediment is pounding up against there or gathering up there, but it's the weight is dispersed through either the wood stakes or the T-posts that you used, 100, 200 yards down the road from where the sediment is binding up. And so you can see there, I don't know if you can tell in the picture or not, but the water is flowing over his hand coming out of the top of the stormwater release version of that. So everything from silt fences backing up to different types of hydromulches and blankets. There's a lot of possibilities there. We talked about vegetation management plans and the importance there, just as a recap. And I like to show this as an interesting Venn diagram I made there. And, there's any number of stakeholders on a successful project with a solar site in the Mid-Atlantic or anywhere really. You've got the developer, the EPC, you've got local inspectors, subcontractors, state entities. But somewhere in there, there's a spot where everybody can be on the same page. And that's really the best use of time and energy for a lot of these BMP products, to make sure everybody understands them, make sure you've got a common goal for vegetation establishment and vegetation management. Remember that they're two different things. So I think that I have actually answered all the questions that have come in through the course of the webinar. There's my information, my cell phone and my email. If you've got further questions, certainly give me a call, reach out to me. We'll be glad to help. We can talk about any number of these products in length if you want to talk about, really get into the weeds on different ones and how they work and where they might be used. Also, if you need a PDH, notice the box on the bottom left there has got a website that you can go to on our website and put in a little information and a code there, and you'll be emailed a PDH usually within 2 to 3 days of the time you do that. And so that's how you can get credit for watching this if you need that continuing education hours. So I'm going to sign off now and say goodbye. Thanks. We've got some great webinars coming up between now and the rest of the year. Make sure you join in, and I hope to see you again. Thanks a lot, folks. We appreciate it, and have a good day.